Hey guys, just want to do a small review on this AEM thermocouple 4-channel amplifier. As you can see, I've got a exhaust manifold here with 4 K-type thermocouples tapped into the exhaust mantle about 2 inches after the exhaust port. And the way a thermocouple works, a thermocouple is a temperature probe, and it's made from 2 dissimilar metals that react with heat to produce a millivolt signal. So the more heat on the thermocouple, the more millivolts the probe will produce. So these thermocouples are wired up to the primary side of this amplifier, as you can see down here. And this amplifier will change and manipulate those signals to a 0 to 5 volt output that can be sent to a Hondata or an engine management system for data logging. Anyway, the main reason I want to talk about this today is there's always a lot of talk and discussion about aftermarket electronics and the accuracy and response time and resolution they can produce. So I've got a Fluke process meter here that has been NATA certified, so it's been off to a laboratory and it's been calibrated and checked to a very high standard. And this process meter can produce and simulate a thermocouple signal. And I've also got here to set up DC volts. So when you actually get the instructions, it will give you, you can see here, like a matrix of voltage versus degrees. You can see it's set up here in 20-degree increments, but what I'm going to do here is actually just step it up in 50-degree increments so it doesn't take so long. Okay. So as the temperature goes up, we should be seeing the voltage value coming out of the amplifier, as every 50 degrees will represent 0.25 of a volt. And after actually going over all 4 channels, it was determined there was approximately about a 1.2% error at the very upper range, so around 1000 degrees, and about a 1% error down at 0 degrees, and it slowly extrapolate out on a linear basis. But the other thing that's really important is these errors, every channel was exactly identical, which is a really good sign. So now that these errors are determined, you can account for that in your engine management system by slightly manipulating your ranges. But another thing you guys may notice is, and this is a big thing when talking about systems set up to measure exhaust gas temperatures, is response time. So even though accuracy is important, response time is also very important. So you can see every time the meter changes the sourced value, there will be a slight lag time between when the sourced value changes and the measured value changes. Now. So that lag time will not wholly and solely be because of the thermocouple amplifier. There will be some lag time within this unit itself, but there is also a deal of lag time between when the Fluke unit changes value and when that value actually gets produced down this wire and into the thermocouple. So part of the lag time will be produced from the Fluke meter itself, and part of the lag time will be produced from the amplifier. There is no way of knowing, unfortunately. But as you can see here, our upper range value, so 1000 degrees, should be representing 5.00 volts, and we're seeing 4.94, which really isn't too bad. It just means on the engine management or Hondata we can basically correct that by ranging 1000 volts to 4.94 volts and not 5 volts, and then extrapolate it down evenly. And that's about it.